Hello students, today we are going to study about the anomalous behavior of water. Generally, when liquid is heated up to certain temperature, it expands and when cool, it contracts. However, water shows a special exceptional behavior. If we heat water from 0 degrees Celsius up to 4 degrees Celsius, it contracts instead of expanding. At 4 degrees Celsius, its temperature is minimum because of contraction. The volume of the we can say that the water at 4 degrees Celsius is minimum. If the water is heated further, it expands and volume increases. It means water shows some exceptional behavior between the temperature 0 degrees Celsius to 4 degrees Celsius. This behavior of water is called anomalous behavior of water. If 1 kg of water is heated from 0 degrees Celsius and its volume is plotted as a function of temperature, we get the graph. In the graph, you can see that at 4 degrees Celsius, the volume of water is minimum. It means that the density of water is maximum at 4 degrees Celsius. Since density and volume both are we can say that the inversely proportional to each other. If volume is minimum, it means density is maximum. Now you can just see the graph, so we can study about the graph one. In that graph, the on x-axis the temperature is noted, while on y-axis the we can say the volume of the water in the we can say that the centimeter cube is 1 kg of water is noted. So you can observe the graph one, and so we'll discuss about that graph. If we look at the graph, the temperature of if the temperature of water is raised from 0 degrees Celsius to 10 degrees Celsius, its volume goes on decreasing in the range 0 degrees Celsius to 4 degrees Celsius. Then its volume is minimum at 4 degrees Celsius. You can look at the graph one there, we can find out that the volume of water is minimum at 4 degrees Celsius. Then if we heat further, the again you can see that the volume goes on increases. So from the graph we can say that the water shows some exceptional behavior between the temperature 0 degrees Celsius to 4 degrees Celsius. Now let us start the Hope's apparatus. This apparatus is used to study the anomalous behavior of water. You can see in that apparatus there is a one cylindrical we can say container is there. Around that container there is a one bowl is attached. Now in that bowl it contains the freezing mixture, that is the ice plus we can say salt is taken in that bowl. Again you can see in the figure the container has the two we can say thermometers. Upper thermometer it shows the temperature T2 and lower temperature it shows the temperature thermometer it shows the temperature T1. In that bowl freezing mixture is there, and first in the container water is taken. Means in that middle container you can see there is a water is there of the we can say room temperature, and we have to note down the temperature T1 and T2. Means before putting the freezing mixture in the bowl, first we have to see the temperature T2, that is the upper we can say that the part, and the temperature T1 of the lower part. Then afterwards we have to put the freezing mixture in the bowl. Initially, you will find out that initially that T1 T2 both the temperatures are same. Once you put the we can say that the freezing mixture in the bowl, slowly the water starts cooling, and the temperature of the we can say that the lower thermometer decreases fast. while the temperature of the, we can say, upper part decreases slowly. Here what happen, when the water gets cool, that time in the beginning we can say that this temperature 0 degree celsius to 4 degree celsius, its volume starts decreasing, and then the that water is there, it slowly, we can say that the moves down. As the, we can say that the volume decreases, means we can say density increases, the water start becoming heavy, it goes down. So the temperature of the, we can say that the lower thermometer decreases fast, while the temperature of the upper part decreases slowly. Then we will find out that the, at one point the temperature of the, we can say that the lower part becomes 4 degrees celsius, it remains constant. Now the temperature of the, we can say that the upper part, that is the T2, starts slowly decreasing till the, we can say that the temperature becomes 4 degrees celsius 1, the it's this process goes on. Then afterwards we'll find out that the temperature of the upper part, that is T2, decreases first. Now instead of T1, now the temperature of the T2 part decreases first now, and then and it becomes 0 degrees celsius, and afterwards the temperature of the lower part, that is T1, decreases fast, and it also gets the temperature 0 degrees celsius. So why it happened like this one, it is because in between the temperature of 0 degrees celsius to 4 degrees celsius, the water shows some anomalous, we can say, behavior. So water, as water cools one, it density, we can say, becomes maximum at 4 degrees celsius, and afterwards we can say that the, after the, once it attains the 4 degrees celsius one, the water starts, we can say that the, it is the density goes on decreases one. So you can see that the first the temperature of the lower thermometer decreases fast, and then the temperature of the upper part decreases one. So it shows the, we can say, anomalous behavior of water. Now you can just see the graph which is shown in the, we can say that the textbook also, or here also you can see the graph. In that graph you can find out that there is an intersection of the two curves, and shows the temperature at which the density of water is maximum. You will find out that the intersection of both the curves, that is the, we can say, the where the both the curves intersect one, that is the 4 degrees celsius one, and at 4 degrees celsius the density of water is maximum. So this curve is useful for finding the density of the water where it is maximum one. Okay, so students, go through the video again, find out the, we can say that the what is the anomalous behavior of water one, and now its applications we'll see in the next video. For today's video, the homework is that just you have to write the Hope's apparatus one, the write about the description about Hope's apparatus, how it works, and the definition of the anomalous behavior of water. Okay, thank you.